So let's start talking now about the gateway microservice that we're defining for this example, for the QuoteServices App case study, and talk about its structure and functionality. And we'll talk about it first at sort of a high level, and then we'll dive later into the source code and see how it's implemented. So you can see here its role. It basically takes these synchronous requests that come in and then uses several other things, including something called Eureka, which we'll talk about briefly here, and we'll talk about it more in the next part of the lesson. And then these are the actual microservices that are doing the work. As you will see when we look at the implementation, and even when I talk about it at a high level here, this code in the gateway is almost entirely declarative. What does that mean? It means we don't have to write very much Java code. We describe things instead using YAML as the description language, which says what you want, not how to do it. So it's the what versus the how. So the Spring Cloud API Gateway, unlike other API gateways you may have been exposed to, has several pieces, several components, and I show them here. And real quickly, this is the way it works. The client sends a request to the gateway. There's a gateway handler that takes the requests, and then it takes a look at the YAML file, which we'll talk about in a second. And then based on the contents of the YAML file, it will parse the incoming requests and figure out how to filter them in various ways and strip stuff off them in various ways, and then forward the requests to the service. And there's also stuff you can do on post-filter, although that's not strictly always required. So let's take a look at what is defined in a YAML file for an API gateway. And one of the most important things here is the concept of a route. And a route consists of an ID, and we'll see where that ID comes from. That's basically the name of the microservice. The destination URI, which says where the microservice is going to be found. The predicates, which are used in order to be able to match the part of the path that corresponds to the name of the microservice. And then what you want to do with that. In other words, do you want to strip it off before you forward it on to the actual microservice? So based on the answers to that, you can find all kinds of interesting things here. A route is matched if the predicate is true. So let's say a request comes in that includes as part of it the handy route name, because it's going to the handy microservice. And this basically says, if there's a match, this is the thing that will match that. So it says, aha, this is for the handy part. And as we'll see, you can either create these programmatically using Java if you want to hurt yourself, or you can use declarative techniques using YAML, which is far easier to work with, which is good. Here's the predicate. Predicates can match requests, and you can match on various things. In this case, we're matching either on the headers or the parts of the URL, the URI. And as you can see here, we're matching on the route names in the path in the URL or the URI that has come in. So that's telling us what microservice is this for. Then you have the filters that can modify the requests before sending things on to the microservice. So for example, here, what we're saying is, hey, if it's coming in for the handy microservice, strip off this part of that URI before you send it on to the microservice, because we don't want to send the handy handle, the route name, to the microservice. It knows what it is. We don't have to tell it anything more about that. So the gateway will strip that off. So let's talk a bit about how this works under the hood, and I'll give you a little foreshadowing of the discussion of Eureka, but that'll come in the next lesson. So the QuoteServices app uses the Spring Cloud API Gateway in conjunction with something called the Eureka server-side discovery service, and we'll talk more about that in a moment. But for right now, basically what this is used for is to locate other microservices that are encapsulated by the gateway by their names. Again, we'll talk about this more in a second. So what happens here is an HTTP request, get or post request in this case, arrives at the gateway, and the gateway is going to work together with the Eureka microservice based on the route that came in to figure out which back-end microservice handles that. Now, this is getting ahead of ourselves a little bit. We'll cover this very shortly. When the whole system starts up, the Eureka microservice has to start up first. You have to start Eureka. Remember that when you do testing of your assignment number 2, when we get to that point, you got to start the microservice first, because everything else registers with it in one way or another. The gateway registers with it and says, hey, I'm the gateway. I want you to work with me to figure out where the microservices are. And the microservices also register and say, hey, I'm alive, I'm a microservice, here's my ID, here's my name. And Eureka keeps track of all that stuff. And so at runtime, after this has all been configured, the gateway consults with Eureka, figures out where the actual applications are running, the microservices, and then it will transparently route the request to the designated microservice. And then the designated microservices controller and the service perform the request, and then they return the result back to the client, potentially bypassing the gateway. So that's basically what's happening in this model. The gateway is configured using this YAML language, which YAML ain't a markup language, but it is a markup language. People always like to have clever recursive acronyms, which if you're not careful, your brain can overflow, right? Because you're trying to expand that indefinitely. This, by the way, is ChatGPT's visualization of YAML, which I thought was pretty funny. At least it was able to spell it correctly. Usually it puts in weird characters and weird letters. So this is what the application YAML file looks like. This is what is used to configure the gateway microservice and to register that microservice with Eureka, which is why Eureka needs to start first. So as you can see here, this is where the gateway will listen. Whoops, it'll listen on port 880. And that's its name, gateway. And it tells it some other configuration things. By the way, ChatGPT is really good at explaining what the various directives in a YAML file mean. And a lot of the documentation I have came from asking ChatGPT. I could have read the manual, but why read the manual when you can use ChatGPT? It's just as good, or better, because it's more to the point. Down here, what we're doing is we're saying, I want to register, the gateway, API gateway, want to register with Eureka. That is true. And this is where you can find Eureka running on my system. Then there's also a YAML file for each of the microservices. So in this case, we put them in the same file. But basically, this is telling us how the gateway is going to route the request to the right place. So here, these are the routes. We talked about these routes before, and they say this is the handy microservice, and this is how you find it. Here's the zippy microservice. This is how you find it. Here's what you do. You strip the prefix, and you send it off to these port numbers. Now, the other thing I should note is if you use Eureka, you don't have to put in the host numbers of the underlying microservices. That's one thing you can do. There's a whole slew of different variations for this stuff. So you can either put the port numbers in and have the Eureka do one piece for you, or you can have Eureka figure out what the port numbers are and allocate and manage them themselves. So that's the end of a quick walkthrough at a high level of the way the gateway microservice is structured.